Morning, KCFR. This is a quick overview video for our new pump chart to be rolled out in conjunction with our new attack hose. A big thanks to Matt Lee for putting this together. As you can already tell, it's very comprehensive and in-depth. Consists of 3 pages, the first 2 being a front and back, very comprehensive and information-packed page, and the purpose of that being to establish a standard, not necessarily to use these first 2 big pages on the scene of a fire, but something you can pull out at the station and use for training and education. And as I mentioned, it sets a standard that we can all reference for all things pump related. And then the last page that will be on its own is the quick reference chart that has everything you need for 9 out of 10 of your structure fires that you'll be on, with a blank notes section next to it if you need to do some math with a dry erase marker. You've got a space to do that. So we'll start at the beginning. The first section in the green, pre-connects, pretty self-explanatory. These numbers are based on Key Hose's own friction loss numbers for the 1 3/4 sniper hose and the 2.5 True ID that we purchased, and these numbers were confirmed on our flow testing. There is some variation, especially with 1 3/4 and cross lay, depending on the truck, and that flow test information is available. But 110 is where the math sits, and that was our most common discharge pressure for cross lays. 90 for the bumper, 90 for your blitz line. Beneath that in the yellow, your extended pre-connects section. This is simply some pre-done math for most common scenarios if you had to extend your blitz line. You've got the first one being a blitz reduced down to one single line of 100 feet, 1 3/4 bundle. And then you've got the same thing except 200 feet, 1 3/4. And then the last but not least, a Y operation with 2 lines of 100 feet of 1 3/4 sniper. Self-explanatory. You've got the math and then your pump discharge pressure. The most important thing to note with this section is simply the difference between the top and bottom discharge pressure with a Y operation flowing 2 lines and flowing a single line. So if you're flowing 2 lines off of a Y and one firefighter shuts their nozzle down, you now have a single line operation that is about 30 psi over pumped, so could be potentially dangerous if you're using your Y, so be cautious of that. The red section beneath that is your friction loss chart. The only thing notable here is the presence of both an 1 3/4 section and 1.78 inch sniper. 1.78 inch is the actual exact internal diameter of our sniper hose per the manufacturer. We do still have some old 1 3/4 hose on our tenders, and you also just have a reference of the difference between friction loss in those 2 kinds of hose. The red next to that, just beneath here, you've got your elevation loss and your appliance loss for a gated Y. That only comes into play above 350 GPMs. You'll add 10 to your whole system. Beneath that, you've got your formulas if you want to do some math, educate new drivers and your coefficients for all the different sizes of hose. The bottom left, deck gun / master stream. Master stream being a ladder pipe. We don't have our portable deck gun bases anymore, but the same principles that apply to the deck gun apply to the ladder pipe. Just need to add elevation, obviously. On the left, tip size with nozzle pressure in parentheses. Next to that, GPM and friction loss associated. This is from various sources on the internet. This friction loss data and confirmed by the ever helpful ChatGPT. That when you increase your flow through that deck gun, you're going to see more friction loss reflected here. It's going to apply to your ladder as well. And your discharge pressures for that total. Your fog stream, depending on your gallonage selected, is going to be discharged between 105 and 125, adjusted for that friction loss. The next chart on the bottom is for the quick attack mercury monitor with two different supplies here. If you use your 2.5 inch blitz with potential to extend it, or your 3 inch, there's a pretty substantial difference in friction loss with those two size lines when you're flowing that much. Your GPM through your mercury monitor is 500 GPMs, and per the manufacturer, that appliance loss is exactly 6 psi. Rounded it to 5, so it's hard to pump exactly 6 psi. Nozzle pressure of 100, and here's the math associated with each line. You top out at 300 feet with your 2.5 due to that substantial friction loss of 50 psi per 100 feet. Your 3 inch, however, is only 20 psi per 100 feet, so you're all the way at 400 feet with room to grow if you need to. Moving on to the back, this is mostly wildland hose information. So again, some whoop-de-doo information for standardizing as well as educating. Not something you're ever going to use on scene. We use the thumb method for pumping wildland operations, right? Send water, thumbs up, thumbs down, you need more, you need less. But if you're ever curious about the math for wildland hose and what you're flowing through it, here it is. Piercing nozzle has been adjusted for friction loss with sniper hose, relay, sprinkler, and on the bottom, last but not least, our hose packages for all of our trucks. Moving over to the quick chart. As I mentioned before, this is what we figured you'd need for 9 out of 10 of your fires. You've got your pre-connects, your deck gun flows, and your friction loss chart for if you need to extend, have any complicated operations, it's all here. Your notes section, if you want to use a dry erase and do some math, that's your section to do it. And that's it. Any questions can be sent to your local hose committee rep. Thanks.